Welcome to the Department of Mechanical Engineering, SIRT Bhopal. I am Dr. Amit Abbas and this is brief description about my qualification. A previous lecture we have seen the brief introduction about the steam turbine, and in this session we are going to see the compounding in a steam turbine. What is compounding, and then why we go for the compounding of steam turbine, and what is pressure compounding, velocity compounding, yeah, everything we have to see. So at first, what is compounding? Compounding in impulse turbine basically we are also going to see in the today's lecture. So if high velocity of steam is allowed to flow through one row of moving blade, it will produce a speed about 30,000 rpm, which is too high for the practical use. So that's why we utilize this rpm into a stage. Multi-staging we will do it in the multi-staging, and that's why we go for the compounding. It is here I have mentioned here, just we are going through this one. It is therefore essential to incorporate some improvement for the practical use and also to achieve high performance. This is possible by making use of more than one set of nozzles and rotors in series keyed to the shaft so that either of the steam pressure or the jet velocity is absorbed by the turbine in stages. This is called as compounding. Two types, as I told you, the velocity compounding and pressure compounding. Either of the above method can or both in combination can be used to reduce the high rotational speed of the single stage turbine. So the velocity compounding of the impulse turbine. The velocity compounding of the impulse turbine was first proposed by C.G. Curtis to solve the problem of single stage impulse turbine to use with high pressure and temperature of steam. The Curtis stage turbine, it is also called as Curtis turbine. This is basically, again, since the name of the inverter was C.G. Curtis, that's why it is also called as Curtis turbine. As it came to be called, is composed of one stage of nozzle and as a single stage turbine followed by two row of moving blade instead of one. These two rows are separated by one row of fixed blade attached to the turbine stator, which has function of redirecting the steam leaving the first row of moving blade to the second row of moving blade. A Curtis stage impulse turbine is shown in the figure. Schematic pressure and absolute steam velocity changes through the stage. In the Curtis turbine, the total enthalpy drop and hence pressure drop occurs in the nozzle so that the pressure remains constant in all the three rows of blades. Let's see how it will be. So here you can see the nozzle. When we have put it the nozzle, this is boiler steam enter from here. This is the shaft which is rotating. I have mentioned the name over here, and this is the rotor, and here is the exhaust steam. Here is the boiler steam. Now nozzle, we have used the nozzle over here, and what is the function of nozzle? Basically, nozzle utilize the pressure energy to convert the kinetic energy. Means it will increase the kinetic energy. That's why the velocity of steam leaving the turbine. So you can see here, this is the velocity and this is pressure. So when we are considering the what nozzle, this is basically nozzle. So you will found there is a huge jump of velocity, and here is the downfall of pressure. You can see, and now this is moving blade. In moving blade, definitely the velocity of steam will get reduced. definitely that kinetic energy is completely transferred to the moving blade. And then a fixed blade, no loss is there. That's why the energy is constant. And again, this is a moving blade, velocity decreased. Again fixed blade, again moving blade, the velocity decreased. Means one nozzle and moving blade, fixed blade, moving blade, fixed blade. These type of combination you will form. Okay. So in the fixed blade, there is no drop of kinetic energy will found. Only drop of kinetic energy will be in moving blade because the kinetic energy of the steam will be transferred to the a moving blade. That's why these type drop you will form. And finally, this is exit velocity. Similarly, the pressure, once the pressure is dropped, pressure is constant throughout. You can see. In the velocity compounding, pressure is only one pressure drop will be observed when it will pass through the nozzle, otherwise pressure is constant throughout. Since the velocity is changing continuously through the moving blade, that's why it is called as velocity compounding. Means we have compounded the velocity, we have compounded the velocity in different staging. Okay, so this is regarding the velocity compounding. Now, this is moving blade and here it is fixed blade. Now this again we have I have shown you here in the what magnified view that here is the nozzle, moving blade, fixed blade, moving blade. This is pressure drop in the nozzle and then fixed throughout pressure. But what about the velocity? Velocity jump takes place in the nozzle and then drop, fix, drop. So in the moving blade, velocity drop you can observe here, and fixed blade, in fixed blade there is no drop of what velocity. So this was regarding the velocity compounding. Just whenever they will ask you in the exam, you need to draw these things inside the examination hall. So this is the velocity triangle, and I will discuss these things with you in the classroom, or later on we will discuss it separately. But at first we have to see the well. So we have to discuss it. This one, the pressure component impulse turbine. So here you can see the basic thing that I have to discuss, that in the what pressure compounded impulse turbine, we have to compound the what pressure. That is very much important. So here you can see there is a this is a pressure, and how pressure is changing, that we need to see it. This is nozzle M for nozzle, M for moving blade. Here it is nozzle, moving blade, nozzle, moving blade. A series of nozzle and moving blade we utilize it for the multi-staging. Okay. So this is here it is nozzle, moving blade, and whenever steam will pass through the nozzle, pressure drop you can see easily. Here it is the pressure drop. Again in the nozzle there is a pressure drop. Here is the pressure drop. Means wherever nozzle you have used, pressure drop you can observe. But there is a constant velocity jump throughout the compounding. So that's why, since the compounding of pressure you have done over here, that's why this is called as pressure compounding. So I will discuss these things very clearly in the next lecture, and I will also discuss some points that I have left behind, that how we will what form the velocity triangle. That is very much important. So okay, so next lecture we will see these things. So thank you again on the behalf of SIRT and the SAGE group. Thank you all.